Okay guys, let's take a look at today's lesson. What we're going to be looking at is day 2 of graphing polar equations. We're going to focus on two distinct types. On day 1 we focused on the cardioids, those types of graphs. Today we're going to focus on two different types. This is one type, and actually they're called roses. I don't think they look very much like a rose. They look like a daisy to me, but I guess calling a curve the daisies is, maybe they didn't like that. They want to call them roses, so that's what they're called. They're called roses. And we really have two different formats. One format is for sine, and one format is for cosine. It just basically gives a different orientation. This A is going to determine the length of the petal. Whether, if A is 2, then the petal is going to be 2 rings long or 2 spaces long. If A is 4, the petal is going to be 4 spaces long. That's what A does. N determines how many petals there are. And so if N is even, then the number of petals are going to be double the value of N. So for example, this one, that equation is like a sine 2 theta, because it has 4 petals. The N would be 2, so we'd have 4 petals. If the N is odd, 3, 5, 7, and so forth, then the number of petals is going to be exactly the same. So for this particular graph, this N value would have been 3 because there's 3 petals. Do you have to memorize that? No, but just sometimes it's helpful to know what you're expected to create. How many petals are you supposed to have? So it's just kind of helpful. The orientation depends on which trig function we're using. Sine, if you look at sine with the 4 petals, notice how the petals are inside each of the quadrants. But if we look at cosine with 4 petals, notice for cosine the petals are actually lying on each of the quadrantals. So it's just oriented differently. It still has 4 petals, it just has a different orientation. Let's look at the orientation of the odd petals. So for sine, if it's like 3, if it's 3 theta, sine 3 theta, then it's oriented this way with one of the petals down here at 3 pi over 2 and the other ones in our first and second quadrant. If it's a cosine version of the 3 theta, then one of the petals is on the polar axis and the other 2 are here. So it's just a different orientation depending on which trig function you get. As far as the number of petals and the size of petals, that's going to be the same regardless of which format that you're looking at. Okay, and that's one type that we're going to explore today. Are there any questions on that particular type? Okay, the second type that we're going to explore are these little guys. They look like little figure 8, these little guys. These are formed with an r squared with a double angle. And this is the type that we do. We don't really, this is the most common type. We don't typically find r squareds with anything else that we're going to deal with. But this is just a special kind. R squared would be a double angle. So what does that mean? Well, really it's this, right? It's this equation. It's the square root. And so how do we graph that? Well, basically what that means for us is that this is a 2. We should have 4 petals. It's a 2. But because it's been square rooted, all of the negative r petals are eliminated. Why? Because r can't be negative. R can only be positive. So we actually are returned just half of the number of petals that we normally would have. Also, the lengths of the petals are square rooted. So if this were r equals 4 cosine 2 theta, then our petals would be 4 spaces long. But this is r squared equals 4 cosine 2 theta. So our petals are going to be the square root of whatever that number is. Okay, so that's just a note to make to yourself. We're going to have an example actually of an even, odd, and this little guy right here. We have 3 examples to work through, so you'll see more what I'm talking about. Alright, so any questions on this one? Okay, then let's go to the next page and let's work some examples. Okay. So what I like to do still is I like to graph the Cartesian graph and then use that as my t-chart. I still do that. you can certainly memorize things and graph them from memory. I don't have a problem with that, but I want to show you how the Cartesian coordinate graph is helpful. So here we have, 5. So 5 is basically telling us the length of the petal. Also, in our Cartesian world, right, we know that's 5 and negative 5. This 2 theta, the 2, remember, is b. So if you recall from last semester, period equals 2 pi over b, right? So the period for this is going to be 2 pi over 2, or pi. This period would be pi. The Cartesian period would be pi. So let's start that out. Let's graph the Cartesian period. So let's see, if one period is pi, then half of that would be pi over 2. Then we keep splitting, half of that would be pi over 4. So pi over 4, pi over 2, so 3 pi over 4. Okay, and it's cosine, so cosine starts at its maximum and then comes down. So we have this kind of thing going on. Okay, so, and it's 2 theta, so how many leaves should I have, or how many petals? I should have 4. Now the really actually cool thing about the Cartesian graph is it really outlines the petals. This piece right here is 1 petal. This is a half of a petal, this is a half of a petal, of course, because it's cosine, right? Cosine is so fussy. Thank you for giving me a half a petal. Why couldn't you give me a whole petal? But it doesn't. So 1 period in Cartesian world does not finish the graph out. I would actually need 2 periods to finish the polar graph out because I need 4 petals. So I'm just going to go ahead and do the 2 periods. So let's see, from pi to 2 pi, I know this would be, 3 pi over 2. And then I have some others, so we go here. Okay. So I have 1, 2, 3 full petals, and then there's a half of a petal, and there's a half of a petal. Okay, so I've got my 4 petals. So let's start our graph. So recall this was theta, and this is r. So at angle measure 0, we are at 5. Okay, and then the curve, this petal curves and comes down till at pi over 4, it's at 0. So it goes like this. Then we're negative here. We're negative. So notice at pi over 2, it's a negative 5. So at pi over 2, instead of being up here positive, it's a negative 5. 1, 2, 3, 4. It's down here. So let's see what's happened. As these r values, they're negative, we're really supposed to be in the first quadrant. Between 0 and pi over 2 is the first quadrant, right? We're supposed to be in the first quadrant, but we have negative r values, which causes us to go to this, it shoots us across, right, to the third quadrant. So we're actually working on this portion right here matches that part of the petal. Okay? And so as we come back up, we're still negative. The angle measure is in, and maybe it would be helpful, I don't know. So this matches this. Okay, that's where that is. Okay, as we come back up, we still have negative r's. My angle measure is actually in the second quadrant, but my r's are negative, so that's going to put me over here, and I'm going to finish this petal. Okay? Now, you don't have to follow this piece by piece. We now know where the petals are going to be, right? We know where they're going to be. We know how they're oriented. We know there's supposed to be 4 of them. And so I can just go ahead and draw all 4 of them. I don't have to follow the graph. There is going to be something that we're going to do in just a second. So let's just finish the graph first. So we finish the graph. 4, 5. So we can see that the petals are going to be on the quadrantals. So there we go. There's our graph. Now what I'm going to do on a quiz or a test is I'm going to highlight a petal, and I'm going to ask you when that petal starts and stops. Okay? Or I'm going to say, you choose a petal, and you tell me when it starts and stops and highlight which petal you've chosen. So we need to know which is which. I need us to understand it to that level. So okay, so let's just say, let's say that I've highlighted, let's say I've highlighted this petal. Okay, and I want to know when that petal starts and stops. Okay, so let's investigate that. The petal is at pi over 2, but notice at pi over 2 we're negative. It's not this petal, is it? Because this petal is that one. So let's keep investigating. Well, at 3 pi over 2, it's a negative r. Ah, so this is that petal. Those match. Okay, you with me? Those match. So where this petal starts and stops is what I want to know. Where that location is right here and this location right here. Those are the 2 points I need. These roses are always going to have the x-axis as the sinusoidal axis. We're not going to be shifting off of that. It's going to be the x-axis, is the sinusoidal axis. So your points are going to be along here. The starting and stopping of the points is going to be along here. So we need to calculate what that would be. So that's 3 pi, so let's figure out. So we've got pi right here, then it starts here. So it looks like it starts at 5 pi over 4. So it starts at 5 pi over 4. Then over here, let's see, it's right over here, so it ends at 7 pi over 4. That's what you would tell me. If that's the petal that I highlighted, that's what you would tell me. Now, how can we find those numbers if we don't know, if we can't figure that out? Well, the petals start and stop when r is 0. That's when they do. Okay, so I would put a 0 here. 0 equals 5 cosine 2 theta. Divide the 5 off. 0 equals cosine 2 theta. Now let's think about our techniques that we use to solve equations, which I know you're so excited with me that you still get to do. You're not, it's not an old thing, it's fresh. We do it all the time. So let's see. So we need to think about where would cosine be 0. Okay, cosine would be 0 at pi over 2 and 3 pi over 2. So we would say 2 theta equals pi over 2 and 2 theta equals 3 pi over 2. Hopefully you remember that technique from last semester. And so we solve for theta. So theta is going to be pi over 4 and theta is going to be 3 pi over 4. Now we're going to make a general solution. Remember, plus, what's the period? What is this period for cosine 2 theta in Cartesian form? It's pi, right? So this will be plus pi in, this will be plus pi in. So this is going to give us, these are going to give us all of our starting and stopping points. If we can't figure it out, perhaps we can use that to help us figure out where it starts and stops. I don't understand the difference between the start and stop that you first did and you Okay, so this start and stop refers to this exact petal. I located this on my Cartesian graph. I've seen that this petal is this petal. And I've looked at these particular starts and stops. These two, and that belongs to just this petal, these two give us the start and stop for all of the petals. It's a general solution. So for example, this petal right here, it starts at 0 and then it goes to pi over 4. Pi over 4 is the ending of this half petal. And then pi over 4 is the starting of this petal right here. Pi over 4 to 3 pi over 4. So pi over 4 is this location right here, and 3 pi over 4 is this location. So those two give us that start and stop. And then if I add pi to this, I get so 4 pi over 4, so 5 pi over 4 I add, and I keep getting more starts and stops. Does that make sense? This would just give us all of them. And we don't generally need all of them, but some students were a little bit worried about how would I find it if I don't know. This is going to give you all of the possibilities. Okay? All right, so any other questions on that problem? Okay, so let's go to the second one. Here we have an odd. N is odd. So it's 6 sine 3 theta. So let's kind of think through this. So what is the length of our petals? 6, right? There's 6 spaces long. And how many petals should we have? We should have 3. So let's do see what our period would be. So P equals 2 pi over B, which is 3. So one Cartesian period would be 2 pi over 3. So let's start the Cartesian graph. So we'd have 6, negative 6. Okay, so one period would be 2 pi over 3. So half of that would be pi over 3. And half of that, let's see, half of pi over 3 would be what? Pi over 6. So I have 1 pi over 6, 2 pi over 6. 3 pi over 6 is what? Pi over 2. So that's one Cartesian period. Let's see how far that gets us with our graph. We know we're supposed to have 3 petals. So sine starts at the sinusoidal axis and then goes up and then down. So like this. Okay, well, one Cartesian period got us 2 petals, right? Got us 2 petals. And we know we're supposed to have 3. So we would actually need more. Now we're probably going to be able to figure out how to graph it with just these 2 petals. Let's kind of investigate. So let's see, when this is our theta, if you recall, this is r. So let's see, when theta is 0, r is 0. When theta is pi over 6, r is 6. So 1, 2, 3, 4, 5, 6. Okay, there's 1 petal. Then I have at pi over 2, I have a negative 6. So pi over 2 would be up here, right? But r is negative, so it's going to shoot me across. So 1, 2, 3, 4, 5, 6. So now I can see where that petal goes. And I can tell by symmetry where the other petal is going to be, but let's say I can't. Well, we would just continue our Cartesian graph. Let's see, we're going by 6, right? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So like that. So there's our third petal. So this was 5 pi over 6. So 1, 2, 3, 4, 5, 6. It gives us our third petal. Now let's just say that I highlighted, say this, is on a quiz or test, and I highlighted this petal. And I'm asking you, where does that petal start and stop? Okay, let's investigate it. So 5 pi over 6, let's see. Yeah, 5 pi over 6 happens to be this petal. So these are the matching petals. This petal matches that petal. So I need to know the start and stop of this one. Okay, are we okay? All right, so let's find the start and stop. Our scale was in 6. 1, 2, 3, so 4 pi over 6. 1, 2, 3, 4, 5, 6. So it starts at 4 pi over 6, which is, what, 2 pi over 3. So it starts at 2 pi over 3, and it ends at pi. That's the start and stop of our petal that was chosen for us. Now, on the daily work, you're going to get to choose which petal you want to highlight. Okay, you just pick which one you want to do. Okay, are we okay with the odd ones? Okay, let's look at our last one. So this last one is the r squared type. We have r squared equals 16 sine 2 theta. So what that does is basically the length of the petal is not going to be 16. It's going to be 4, right? We would square root the length. The 2 theta means that I really should have 4 petals, but because it's squared, half of them are going to be eliminated. So let's do the Cartesian graph of this. What we're going to graph is 4 sine 2 theta. That's what we're going to graph. So with 4, negative 4, it's our period is pi. So pi over 2. What do we have? Pi over 4. 3 pi over 4. So it's sine, so it starts the sinusoidal axis and goes like this. Now what's happening here is that petal that falls under the x-axis in my Cartesian graph, that petal is going to be eliminated. Okay, why? Why is that petal? So we're going to cross this petal off. It's eliminated. Why is it eliminated? It's eliminated because this is actually r equals the square root of, so 4 square root of sine 2 theta. All of these r values are positive. There aren't any negative r values. That's impossible. Right? That's impossible. So when I square root both sides, that turns into, you know, r, and this one turns, we're just using the r. We're not, so mathematically, could it be a plus minus? Yes, mathematically it's a plus minus, but that really has no meaning for us because, you know, what does the negative r do for us? You know, so we just need to graph one or the other. One or the other, not both. They're both going to generate the same graph, so I'm going with the positive one. So I need only positive ones, so I can only have this petal, I can't have that one. So I actually, well, we know there's supposed to be 2 petals, so let's keep going. So we'll do the other period. So pi, that would be what, 3 pi over 2. So here we go. So now this last petal is the one that is gotten rid of. That's gone. And I just have 2 petals to graph. So let's see. I start at 0. I go to pi over 4 at 4. Right here. So there's one of my loops. Then that other petal's gone. So then we do here. So what was that? That went pi, 3 pi over 2. So that's right in the middle over here. Right at 5 pi over 4. And so there's my graph. Find the point which the petal begins and ends. So we could pick either one. I don't know. Let's, who knows? Let's, just for fun, let's pick this one. Which is this one. Okay, so where does that one begin and end? Let's see, it starts at pi and it ends at 3 pi over 2. Okay, how are we doing? Are we okay with this? So we got a good grasp on the petals? Oh, you can if you want to, but there's just 2 petals, so you certainly could solve and get a general solution, but I normally don't on this kind. So this one actually took, well, it took 2 Cartesian periods to create this graph. I guess if we don't count this, I suppose a period and a half. But this period would be, the Cartesian period would be pi. Yeah. Okay, anything else? Are we okay?